Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, the Science and Technology channel.
Yep. And you all know, if you've listened to our channel for a bit, you know that we love to talk about space. And especially if we're talking about space and involving this James Webb Space Telescope. And we're talking about both of those things today and what it saw. So this is cool. As you can see there, you can see what it saw. So.
Yeah, so this is an artist rendition, but this is the kind of stuff that the James Webb Space Telescope is picking up. And we're going to see a little bit further the actual image. All right. New observations from the James Webb Space Telescope show that IRS-3, a star near the center of the Milky Way, is losing vast amounts of mass, causing its surrounding envelope to expand continuously. Near the supermassive black hole at the center of the Milky Way, a mature star is shedding enormous amounts of gas and dust into space. Now, I'm just going to say, if you think that this is all random, you are completely wrong. This is like Circle of Life, but on a cosmic scale. The Heavenly Father redistributes energy and mass in a continual cycle over eons and eons and eons, worlds without end. Am I right, Scott?
And this is what happens to you when you just eat everything, right?
Yeah.
You have enormous amounts of gas and dust. So,
okay. Near the supermassive black hole at the center of the Milky Way, a mature star is shedding enormous amounts of gas and dust into space. Observation of IRS-3 suggests that this material has created an exceptionally large envelope, and within it, astronomers have detected water molecules despite the extreme environment surrounding the galactic center. Would you like to know more?
Okay, the research was led by PD, Doctor, I don't know what that is, PD, Florian Peisker, of the University of Cologne's Institute of Astrophysics. Peisker's group, which participates in the European James Webb Space Telescope Consortium, which I didn't even know there was one of those, studying nearby galaxies. But you've said about that, right? All these agencies or groups, they put in their time when they can use this telescope, right? Got to make reservations, whatever.
So. And also, they use AI to just examine the data that's collected, because these groups, they're looking at one single thing, but the telescope is picking up many things. It has many instruments on it.
Okay. And this consortium is studying at nearby galaxies, investigates the region surrounding Sagittarius A, the supermassive black hole at the center of the Milky Way. The findings were published in the journal Astronomy and Astrophysics on August 11th of this year.
To examine IRS-3, the astronomers used James Webb Space Telescope's mid-infrared instrument, MIRI, which observes the universe at mid-infrared wavelengths and was developed in part at the Institute for Astrophysics. IRS-3 lies roughly a half a light year, or 42,000 astronomical units, from SGR-A, that black hole.
1 astronomical unit is the average distance between Earth and the Sun. Voyager 1, which we just talked about yesterday, or at least the Voyager program, the most distant human-made object from Earth would require about 10,000 years to travel that distance. On galactic scales, however, IRS-3 sits remarkably close to the black hole.
So, remarkably close, half a light year, 42,000 times the distance between Earth and Sun, and that's relatively close. Okay, I'll take their word for it. IRS-3 is
remember, we're not speaking on man's terms.
Yeah, exactly. Yeah.
Right.
IRS-3 is surrounded, and even though it's this close, it's still being sucked up by the black hole. That's crazy.
Yeah.
IRS-3 is surrounded by an envelope extending about 10,000 astronomical units from the star. Large envelopes can form around mature stars, but IRS-3 is unusual because no comparable object is known in its immediate surroundings, despite the millions of stars near Sagittarius A, which is that black hole. Let me advance the slide here.
Detailed observation. Oh, there you go. New slide. Okay. Detailed observations with MIRI also changed the picture of what IRS-3 is currently doing. Contrary to earlier studies, Peisker and his colleagues concluded that the star is undergoing a phase known as a superwind. In astrophysics, a superwind describes a period of extremely rapid mass loss near the end of a massive star's life, during which enormous quantities of gas and dust, there we go again with that, are expelled into the surrounding environment over centuries.
The researchers estimate that IRS-3 is losing an amount of material equivalent to Earth's mass roughly every 18 days. Wow. Continually expanding its surrounding envelope. That rapid mass loss helps account for both the envelope's unusual size and its density.
Most unexpectedly, James Webb Space Telescope's observations revealed water inside the envelope. Wow. Earlier assumptions suggested that radiation associated with, is that Sagittarius, right? Sagittarius A?
Yeah, the black hole.
Yeah, and its surroundings would make it difficult for molecules to survive so close to the black hole. The detection shows that water can persist within the material surrounding IRS-3 and suggests that the star is contributing molecular material to the environment surrounding Sagittarius A, including compounds associated with the fundamental building blocks of life. Oh, okay.
Redistribution.
Yeah.
Researchers and Professor Dr. Lucas Labade's group at the Institute for Astrophysics are now developing a new generation of instruments for the extremely large telescope in Chile's Atacama Desert, which we talked about before, which is expected to begin operations in the coming years. With the METIS instrument, METIS, astronomers hope to investigate the structure and composition of IRS-3's vast envelope in greater detail.
So what's to say that these black holes are not just consuming stuff like they're just gluttons? They're consuming stuff, if I'm reading that right, in that segment that I read, fundamental building blocks of life. They're consuming stuff to create another planet. And then that's
star,
or
which
star,
has planets, yeah.
Right? Or a dwarf planet like we talked about, or whatever, right?
Over millions and billions of years.
Yeah. So they're in the process of maybe cleaning up junk in the solar system or in the atmosphere or the space and using that stuff to create new worlds.
Yeah, okay. I'm catching what you're pitching. I'm catching what you're pitching.
Yeah. So I don't know.
Not
so
random.
Not
random.
Not afraid of black holes. I'm now kind of intrigued about black holes because I'm imagining you're clipping along in your space traveling device or Voyager 1 or Voyager 2, and all of a sudden you get sucked into this thing and your history. But maybe it's selective on what it takes in.
I don't know. I don't know how it can have a little. I think it takes anything in. That
you sure?
You can't escape it. Yeah.
And then so that isn't a negative effect then. So somehow the Voyagers, because they're the ones that are out there the farthest that we know of, they've been able to avoid these things.
Yeah.
You can't really see them, right?
I don't know. Yeah, I'm not the expert. I'm the messenger.
Yeah, no, I know. We're just throwing stuff around here. So, yeah.
Well, okay. I think you can see them because they're detected, so we know where they are.
So they can divert.
Yeah.
They can divert these craft away from it.
Yeah, or send it specifically into it just to take measurements and data.
And then try to get out.
No, then send the data back. The probe would be destroyed in the process and become, building blocks for later things.
Right. Okay. Interesting. Okay.
All right, folks. Thanks for joining us. Hope you have a great Sabbath tomorrow. We'll see you on Monday.
Yep. Enjoy the rest of your weekend, and we'll see you Monday morning. Take care.